Let's practice applying our understanding of implicit differentiation to find the equation of a tangent line to a particular equation together. To get the most out of this video, I encourage you to grab some paper, something to write with, and let's do some math together. So I'm going to go ahead and start by just writing our original equation down first. And that's this right here. We have x to the fourth power plus y to the second power is equal to 3. First things first, let's go ahead and apply our implicit differentiation and take the derivative with respect to x on both sides. So on the left side of the equation, we'll take this d dx of this x to the fourth power plus y to the second power. That's going to be equal to d dx of this 3 on the right side of the equation. Alright, so let's just go ahead and take some derivatives together. Go ahead and use the power rule here. The derivative of this x to the fourth power is going to be 4 times x to the third power. Then for the derivative of this y to the second power, let's go ahead and use that power rule again. If we go ahead and bring that 2 in front, it's going to be 2 multiplied by y to the first power. But then don't forget that we have to multiply this by dy dx whenever we have a y term. But you can also write y prime if you want to, just to save a little bit of time. But feel free to write dy dx or y prime, up to you. Now on the right side of the equation, this one's a little bit more straightforward. If you just go ahead and take the derivative of a constant like 3, you're going to always end up getting 0. So the derivative of 3 is just going to be 0. All right, so we're looking for dy dx, or this y prime here. So let's go ahead and subtract this 4x to the third power from both sides of the equation. If we go ahead and do that, we're going to end up with this 2y multiplied by y prime. That's going to be equal to negative 4x to the third power. And remember, we're trying to get this y prime alone, or this dy dx, so we're going to go ahead and highlight that different color. And let's go ahead and divide both sides by this 2y here so that we can get that y prime alone. So if we divide both sides by 2y, we're going to get y prime is equal to, and then we're going to have this negative 4x to the third power over this 2y. And I think we can divide both top and bottom by 2 here, right? So if we go ahead and do that, we're going to end up with, I'll put a negative in the middle here, and have 2x to the third power just over y. And so if you want to go ahead and rewrite this using dy dx, just because you're more familiar with that, or it's just a little bit more clear, this is going to be the instantaneous rate of change of this equation. So dy dx is going to be this negative 2x to the third power over y. All right, so this tells us the instantaneous rate of change on this equation at any given point. But what specific point are we given here? Well, we're given this x value of 1 and this y value of negative root 2. So we want to find the instantaneous rate of change at that specific point. So let's go ahead and find the slope of the tangent line at the given point 1 comma negative root 2. All right, so we know the slope, or the instantaneous rate of change, is going to be at this expression of negative 2x to the third power over y. And we know what our x and y are going to be. We know it's going to be 1 for x and negative root 2 for y. So plugging that in, we're going to get negative 2 multiplied by this 1 raised to the third power. And this is going to be all over this negative root 2. All right, so keep in mind we have a negative over negative, which is just going to be positive. So on top here, 1 cubed is just going to be 1 times 2 is going to be 2. So we're going to get 2 over this root 2 here. All right. Now, if you wanted to go ahead and rationalize the denominator, you can multiply top and bottom by root 2. We're going to get 2 root 2 over 2. And then you can simplify the 2 over 2 and just end up with root 2. So that's actually going to be the slope at this given point. All right, so keep in mind that we had this point of 1 comma negative root 2. And that's a point that exists on this graph of x to the fourth power plus y to the second power is equal to 3. We know we can draw a tangent line through the point 1 comma negative root 2, and that tangent line is going to have a slope of this root 2 over here. So let's go ahead and use that point and that slope together to find the equation of that tangent line. All right, first you're going to want to know this equation right here, which is really just point slope form. And so substituting in here, we're going to say y minus, and y1 is going to be that negative root 2. I'm going to go ahead and write, it's going to be negative root 2, just like this. And then we're going to go ahead and say that's going to be equal to m, which is this root 2. Let's go ahead and substitute that in. And that's going to be multiplied by the quantity of x minus x1. Now x1 we know is going to be 1. That's the point that it's going through, or the x coordinate of it. And so that's going to be the x1, y1 plugged in, as well as the slope. And then just cleaning this up a little bit on the left side, y minus this negative root 2, you can say it's y plus this root 2. And that's going to be equal to root 2 multiplied by the quantity of x minus 1. This right here would be the equation of the tangent line that is going to hit that point of 1 comma negative root 2 on the equation x squared plus y squared is equal to 3. So let's go ahead and take a look and see what this would look like on a graph together so you can kind of visualize and put all the pieces together. So what I'm going to go ahead and do is just take this original equation and put that into Desmos, or put it on a graphing calculator. So what I'm going to do is just take this original equation and throw it onto Desmos or any graphing calculator. I'm also going to plot this point of 1 comma negative root 2, and then I'm also going to go ahead and graph this equation of this tangent line as well, so you can see them all together. Alright, so let's look at this down below here. So we have our original equation here, x to the 4th power plus this y to the 2nd power is equal to 3, okay? And we have this point of tangency here that we were given of 1 comma negative root 2. So that's where that tangent line is going to kind of hit that equation. And then we can kind of see our actual tangent line here. This, we came up with the equation earlier. We said it was going to be y plus that root 2. That's equal to the root 2. That was a slope we found out, this particular root 2, multiplied by the quantity of x minus 1. And hopefully it makes sense that this slope is positive here, because if you look at the point of tangency and where it is on the equation, if you're going to draw a line that is tangent to this equation at that point, it's got to have a positive slope here, right? If you wanted to find the rise over run between any 2 points that are on this purple line here, or the line that is tangent, you would get this root 2, because that's the slope of it. Alright, so that wraps up this example of finding the equation of a tangent line to an equation using implicit differentiation. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might find it helpful as well. And as always, keep up the great work that you're already doing.